Greetings, students, scholars, and curious viewers. This is Mr. SKT, or otherwise known as the Super Kuroishi teacher. In today's lesson, we're going to be doing the next section on algebraic equations, dealing with word problems. Without further ado, let's begin. So the biggest obstacle that mathematics students find is that word problems aren't given in mathematics. They're given in English or the language that you are studying mathematics in other words, your language of medium. So the true test of word problems, what it's testing is your ability to translate that language in the case of me for English into mathematics. Because if you remember in some of my previous videos, I refer to mathematics, and I wholeheartedly believe mathematics is a language, and word problems is where we are translating English language into mathematical language. So the first thing I thought that we should tackle before we get on to actual word problems is what to do in the case of keywords. So in other words, there are certain words that will be presented to you in the word problems, and each of them correlate with a certain mathematical instruction. Just like when you are learning another language, when you are reading a sentence, you are not reading the sentence as a whole. You are looking for keywords in which you can then piece together what the sentence is saying. So the first thing I want to show is literally is. If you see the word is in the word problem, that basically refers to an equal sign, or is usually giving the result if it's by itself. So for example, a certain number is 8. So in mathematics, you can just simply write that as x equals 8. If you remember from basics of algebra, a variable, a letter, can be used to represent a number. So here, x is being used to represent a certain number, and we are saying x equals 8 because that certain number is 8. Right. If you see the words sum, increased, total, and more, each of those words is associated with the mathematical operation of addition. So some examples include the sum of a certain number and 3. That means x plus 3. A certain number increased by 4. Another way of writing that is something like y plus 4. I used y in this case because any letter can be used to represent a number in algebra. So in order to keep things from getting stale, I decided to use a different letter. It could be x, it could be y, it could be a, it could be k, it could be s, it could be whatever. But it's just any letter used to represent a number, as long as it's not Greek, because those are usually used for angles. The total of a number and another number is 12. So here's what that would look like in mathematics. Using a to represent a number and using b to represent another number. Why am I using two letters? Because we are not told what the values of either of those certain numbers are. So I'm using two letters to represent each of them. So a plus b equals 12. And you can say equals to 12 because there's the is. A certain number is 5 more than another number. So so here, reading the sentence carefully, a certain number is 5 more than another number. So there are two unknowns involved here. The first one, x, and I'm starting it with x equals because you can. It says a certain number is. And it's 5 more than another number. So that means that's the other number, which is y, plus another 5. That's some addition involved there. Now the next one. If you see the words difference, decreased, and less, these words are associated with the operation of subtraction. If you see the difference between a certain number and 6, that can be translated into x minus 6. If you see a number decreased by 10, you can translate that as, let's say, a minus 10. Remember, as I said, the letters don't have to be the same letters all the time. As long as if there's one letter, there is the sole letter over there. What the hell did I just say there? Anyway, 15 is 2 less than a certain number. So you see there, 15 is, so that's why you can start it as 15 equals, and 2 less than a certain number. So you have to use some common sense there. Even though it says 2 less, you don't start it with 2 minus. No, 2 less than a certain number. So that means you're going to start with the other number and then decrease it by 2. Alright. And that's pretty much addition and subtraction. If you see the words product, multiply, and any word that suggests a number multiplier, like twice, triple, double, quadruple, these are all symbols or sign or commands for multiplication. The product of a number and 4 is 48. Product is the result of a multiplication. So therefore, the product of a number and 4 is the same as saying a or x or whatever times 4 equals 48. And if you remember from your conventions of algebra, you can actually rewrite that as 4a equals 48. Two sides of the same coin, they're both basically the same. If you multiply a certain number and 13, you get 52. So multiply a certain number and 13. So in this case, I said b times 13. You get 52, which equals 52. You can otherwise rewrite it as 13b equals 52. Twice a certain number is equal to triple another number. The word twice is a times 2 multiplier. Triple is a times 3 multiplier. So twice a certain number, so I'm using twice x, and that's equal to triple, which is 3 times another number. So I won't be using x for the other one, I'll be using a different letter, which in this case I used y. You could use a or b or whatever as long as it's not x, because it's different from the first number by the wording of the question. And that's some multiplication there. Let's go on to the next one. If you see the words quotient and divided, it's of course a command for division. The word quotient over here, it refers to the result of a division problem. So the quotient of two numbers is equal to 6. So that means one number divided by another number will give you 6. So I decided to use I and J this time because at the time of making this video, I was feeling hungry. So I divided by J will equal 6. It could even be J divided by I because we were not told which one was being divided by. So this is a very rare situation, but that's why when you get the actual word problem, they will specify to you what's being divided by what to avoid confusion. So in this case, because I had I and j like this, you can actually rewrite it as I divided by j, which equals 6. A certain number divided by 3. Now this is where it's worded properly. Here, they're telling you what is being divided by what. So here I put a certain number being represented by k being divided by 3. So you have k divided by 3. Or you could represent it as k over 3 in a fraction form. And that's it for the division, actually. But now I have some miscellaneous ones, or some that don't fit into any of the other categories. But these are rather important because these often are put in the test quite a bit. The first word I want to go over with you is the word consecutive. When something is consecutive, or if numbers are consecutive, that means they essentially follow one another. For example, the numbers 1, 2, 3 are all consecutive numbers because they follow each other. -4, -5, -6, or even -5, -4, -3, they are also all considered consecutive with each other because each set they follow one another. And you notice that with consecutive numbers, they either increase or decrease by 1 each time. So the best thing to do when you are confronted with consecutive numbers in a question is let the smallest one equal x, because then the next one will be x plus 1. If you have for example, like this, if you have 12, the next consecutive number is 13, which is 1 more. And the next consecutive number to that is 14, which is 1 more. So that's why you add another 1 there. Okay, that's consecutive numbers. Then an even number. We all know even numbers 2, 4, 6, 8, 10, and well, any number that ends in 2, 4, 6, 8, and 0. So in other words, an even number is divisible by 2. So since every even number is divisible by 2, we can actually represent it as 2x. Why 2x is because if you take any number and multiply it by 2, the result will be even. That's why we can use that. Just like how with an odd number is every number in between an even number. So in other words, if you took an even number, any even number, and you either add or subtract 1, you will get an odd number. That's why we can use 2x plus 1 or 2x minus 1, whichever one it like fits the situation. Personally, I prefer adding 1 because I prefer keeping my values positive. That's just me. If you feel like using like 2x minus 1 would generate you some advantage, then by all means. Then consecutive even numbers. Now, so combining consecutive and even numbers. So an example of consecutive even numbers will be like 4, 6, and 8. The first one starts off as an even number, so we can represent it as 2x. But the next one is 6. That's 2 more than the lowest one, which is why you would put 2x plus 2. But then the next one is 2 more than that, so you add another 2, which is why it would be 2x plus 4, and then it would continue on. For consecutive odd numbers, you would start off with your odd number, which will be represented as 2x plus 1 or minus 1, whichever. And then the next one, odd numbers go up in 2s. 3, 5, and 7. 5 is 2 more than 3, and 7 is 2 more than 5. So in order to go to the next odd number, you would need to add 2. So in my case, I would have from 2x plus 1, it would jump to 2x plus 3. And then the next one will be another 2, which will be 2x plus 5. And I will continue on. And with that, that's just the keywords. That's just some of the keywords to act as like the vocabulary for word problems. Now let's go into some actual examples dealing with how to answer word problems. And the main technique is let something equal x. Well, x or y or any x, y, a, b, whatever letter you are comfortable with, as long as you let a letter represent what you want to solve. So, for example, example 1, a certain number is increased by 8 to get an answer of 17. What is that number? So you are essentially going to be reading the question and translating it as you go. So that certain number over there needs to be represented by some unknown. So in this case, I'm going to be using x. And I'm going to say, I'm going to let that number equal x. So this is the first step in allowing me to actually turn it into a mathematical sentence from English. So that certain number, which I'm calling x, is increased by 8. Increase means addition. So that's why you say x plus 8. It's increased by 8 to get an answer of 17. To get an answer of 17, so that's an equals. So that whole sentence translates to x plus 8 equals 17. And from there, I just need to answer the question of what is that number. So from there, it's now an equation. It's now an algebraic equation. I can now just move that to the other side. X is equal to 17 minus 8, giving me an answer of 9. And there you go. The moment you turn that to an algebraic equation, it's just your basic algebra coming into play. You don't need to translate it anymore. That one was a bit too easy for you, wasn't it? Let's move on to a nicer one. A number is decreased by 5, then it is doubled. The result of this is 12. What is the original number? Okay, now this one goes in parts. This is the type of question that Yu-Gi-Oh players will love, because they love that problem-solving card text. So what's happening here is so an instruction is given, so a number, so I'm going to say let that original number be x, because why not? A number is decreased by 5. We know decrease means subtraction, so that's fine. But then it says then. So based on the wording of the question, it seems the act of doubling happens after the number is decreased by 5. So it looks like we start off with x and then decrease by 5 to give it a minus 5. And then that whole thing, that result, is then doubled to get an answer of 12. So it should look like x minus 5, all in a bracket, times 2 equals 12. We're only doing that because of having to do that because of the wording indicates to us that the doubling happens after the decreasing by 5. But from there, move that to, you can now just do your distributive law and actually sort out, well, you don't even have to do distributive law if you don't want to. You can just move that 2 to the other side. But the main point thing is you need to solve for x from there because you've actually set it up. So I did the distributive method because I'm an idiot. Move that over to the other side. That makes it 22. Then divide both by 22, and then your answer should be 11. So your original number by our calculations is 11. And let's see, and let us check by actually putting it back into the original place. So if we took 11 and we decreased it by 5, we would get 6. Then it is doubled. 6 times 2, and then is our result 12? Yes, it is. 11 checks out. It is the correct answer. All right. So that one was a little bit tougher, but that's a little demonstration on how people can get caught out, or how the sort of like the wording of the sentence makes such a difference. Makes why it matters so much. Now, example 3, I put a little hint in here. Well, not so much a hint, more like another situation. If there is more than one unknown number or value, try to relate them to the one that you've made equal x. For example, Daniel is twice as old as Saifan. The sum of their ages is 45. How old are each of them? Is it are each of them or is each of them? My English is not as good as my maths. Alright, so here I have two boys whose ages are unknown, but we know that the sum of their ages is 45. So where do we start usually? Well, based on the wording of this sentence, it appears that Saifan is the younger of the two. It is generally encouraged that you make the smaller number equal your unknown, equal to the letter that you're using, because then you will just be going up instead of down. So it will, truth be told, it doesn't matter whether you make Saifan equal x or whether you make Daniel equal x. But I generally prefer making the smaller one equal x, because it avoids negatives and avoids fractions. That's personally why I do it. Anyway, so I'm going to let Saifan's age equal x. And therefore, by the wording of the question, Daniel is twice as old as Saifan. Twice is a number modifier of times 2. So that means Daniel's age would be 2x. So now that I've established what our unknowns are, now I can read the rest of the sentence and see if I can actually use them. The sum of their ages is 45. How old are each of them? So if I add the two of them together, which is x plus 2x, will equal 45. Then from there, x plus 2x will give me 3x. And then I can work out from there that x equals 45 divided by 3, which is 15. So it's fine and dandy that we've got x equals 15, but now we need to actually answer the original question, which is, how old are each of them? Well, we made Saifan equal x, and we made Daniel equal 2x. We've got our x value. So that means Saifan is 15 years old, and Daniel is 2 times 15, which will make him 30 years old. And then we have that one done. I have just one more that I want to show you, just to show you a different scenario, which is make sure to answer the question, because one can get wrapped up with finding out the value of x and everything, but at the end of the day, you need to make sure you answer the question. So here, the sum of 3 consecutive numbers is equal to 114. What is the middle number? Okay, so we're dealing with 3 consecutive numbers. So you have a smaller number, a bigger number, and a larger number. Well, it's more like a small number, the one after that, and the one after that. So what I'm doing is I'm letting the smallest number equal x. So if the smallest number is equal to x, that means the one next after that will be x plus 1. And then the one after that will be x plus 2, because consecutive numbers go up in ones. So the sum of them is equal to 114. So which means if I add all three of them together, I will get 114. And from there, I'm going to now sort out my like terms. X plus x plus x gives me 3x. 1 plus 2 gives me 3. Then get the 3 over to the other side. It becomes a negative 3. So I get 3x equals 111. And then x equals 111 divided by 3, which gives you 37. At this point, many people will stop and they think, yay, okay, we have x. We're done. Are we? Read the question again. What is the middle number? You let the smallest number equal x. The middle number is x plus 1. So, therefore, the middle number is actually 37 plus 1, which is actually 38. That's what the answer to the question would be. That being said, students, I have prepped for you a very small exercise this time, in which you can get a little bit of practice now on your word problems. I'm going to, just like all the other time, I'm going to scroll down very slowly so you get a good read for each of them. Okay, if you wish, and then focus, there we go. If you wish to do this by yourself, I'm giving you the option to pause the video in 3, 2, 1. Okay, let's do the correction. Right, there was only 4 that we had to do, so this shouldn't take us too long. So the first one, 3 times a certain number is equal to that same number increased by 24. What is that number? Okay, 3 times a certain number, so that means 3 times, I'm going to make, so start off with let the certain number equal x. 3 times a certain number, so that's going to be 3x. And that's equal to that same number increased by 24. So 3x equals x plus 24. And from there, move the x over to the other side because we're dealing with algebraic equations. You should know how to do this by now. Take that x over to the other side. That positive x becomes a negative x. 3x minus x will give us 2x. Move that 2 over to the other side. Multiplication by 2 on one side becomes division by 2 on the other. Therefore, what is that number? That number is 12. Next, Tabo has 5 rand more than Becky. With their money combined, they buy themselves each a 13 rand ice cream, which with today's inflation and the year that is, that's bloody good. How much did each boy have? Okay, now based on the wording of the sentence, Mbeki has less money. So I am going to make Mbeki equal x, which means Tabo, who has 5 rand more, would be x plus 5. So their money combined let them buy each a 13 rand ice cream. So I'm adding x and x plus 5 together, and there are 2 of them, each buying a 13 rand ice cream, so that's equal to 13 times 2. So that means at the left side, that would be 2x plus 5 equals 26. Bring the x over, bring the 5 over to the other side, becomes minus 5, becoming 21. 2x equals 21. Therefore, x equals 21 divided by 2, which is 10.5. But in money terms, that will be 10 rands and 50 cents. The actual question, remember, is how much did each boy have? So we made Mbeki equal x. So that means Mbeki had 10 rand 50 cents, and Tabo, who had 5 rand more, had 15 rand and 50 cents. Out of Tom, Richard, and Harry, Tom is the youngest. Harry is 6 years older, Tom is the youngest, Richard is 6 years older, and Harry is 3 times as old as Richard. How old would Tom be if Harry is 39? So here, this is a situation where we are going forwards in order to go backwards. Yes, mathematics makes you do this kind of shit. Right. So here, because Tom is the youngest, because I just flat out said that, we are letting Tom's age equal X. Richard is 6 years older, so that means Richard will be X plus 6. And Harry is 3 times as old as Richard, so that means we're going to take Richard's age and multiply the entire thing by 3, and from there you get Harry's age. How old will Tom be if Harry is 39? So that means we are trying to solve for X if Harry's age is equal to 39. So 3 into X plus 6 equals 39. And from there, I'm just going to take the 3 over to the other side because that's going to make things easier. Divide the 39 by 3 and I get X plus 6 equals 13. And then I take the 6 over, that plus 6 is going to become a minus 6. X equals 13 minus 6, which is 7. Therefore, Tom's age is 7. And then finally, this one seemed a bit tricky, but let me show you how this was done. A furniture dealer has 4-legged and 6-legged tables in stock. There are 48 tables in total, with a total number of table legs equal to 172. How many tables of each kind does he have in stock? Okay. So what I did for this one is I made the number of 4-legged tables equal X. You could do the same with the 3-legged. You could start it with the 3-legged tables if you really wanted to. I did the 4-legged ones. But if you start with 3-legged, if you did everything correctly, you would end up with the same answer that I got. Okay, so since I'm letting the number of 4-legged tables equal X, that means the number of 3-legged tables, since there are 48 tables in total, that means 3-legged tables will be 48 minus X. Since I would add those two up to get 48. And with that, that means the number of legs the 4-legged tables have is 4x. And that means the number of legs the 3-legged tables have is 3 times the 48 minus x, because that's 3 times the number of tables for the 3-legged tables. Which I did sort of help out by distributive lowering that, turning it into 144 minus 3x. So the next step, now that we've set up sort of like representations for the number of legs, now we can sort out the main clue. The total number of legs is 172. That means that 4x and that 144 minus the 3x has to give us 172. So therefore, 4x minus 3x, which is x, and equals 172 minus 144. Therefore, giving us 28. X equals 28. And if you recall, I made the number of 4-legged tables equal x. So therefore, there should be 28 4-legged tables. And the number of 3-legged tables is 48 minus x, which is 48 minus 28, which is thus 23-legged tables. Whew. And there we have, students. That's pretty much word problems. That will service you not only for grade 8, but serve as a great foundation towards grade 9 and upwards. If you enjoyed this content, please leave a like, share with your friends, and subscribe, and comment on what you want to see next. With that being said, Have a nice day.